All right, hey there, Earth Science students. Today we're going to be continuing our unit on mapping. So we're going to be looking how do we display data on a map. So the first thing we want to talk about is a field or field map. This is a map that displays data over a geographic area. So we've looked at these before where they've shown our temperature, pressure, and a little bit with elevation. So that's what we're going to be focusing on for this unit, is we're going to be talking about how maps are able to show elevation. So here's an example of a field map that's showing temperature, right? So we can see that different temperatures are indicated by different colors on this map. And we can kind of see, the isotherms aren't actually on here, but we can see where each of those colors is divided and where one set of temperatures stops and one set of temperatures begins. So what kind of field maps have we seen before? This is one for snowfall totals. We can see by looking at this map really quick, we can see where our snowfall totals are the greatest and where they are the least. So field maps are really great at showing data visually, so we can get a quick snapshot, a quick idea of what's going on in a particular area. All right, so how do we group that data together? We're going to be using something called ISO lines. So ISO lines are what we are going to be using to connect equal values onto a field map. Now there are different types of ISO lines, and each of these different types of ISO lines kind of gets a different name depending on what type of information it's connecting. So some examples. Isotherms are going to be connecting equal temperature, right? You see that therm in the name, you know we're talking about temperature. Isobars, these are going to be connecting areas of equal pressure, equal air pressure. Same thing. Anything that has bar in it, B-A-R-S, bars, anything like that is going to be only dealing with pressure. Think about a barometer. That's what we use to measure pressure. And finally, contour lines are going to be connecting areas of equal elevation because they're going to be showing the contours or the shapes of the landscape. All right, let's take a look at some of the rules for drawing our ISO lines. So the first thing, we want to make sure that we are drawing our lines carefully, right? In order to make sure that they are accurate. Each one of these lines represents a specific elevation, so we need to make sure that it's in the right spot. We're not going to skip any contour values, right? Once we know our contour interval, what we're changing our lines by, we're going to have to make sure that each one of those is located somewhere on our map. ISO lines are going to form closed loops or edges, right? That means that they are going to be always connecting to each other or extending to the edges of the map. ISO lines are also never going to touch each other, right? They can't cross or touch because that would mean that we'd have two different data points in one location. You can't be at two different elevations at the same exact time. All points on an ISO line are equal to one another, right? They are always going to be equal. If we have a line that says we are at 500 feet elevation, it's always going to stay at 500 feet elevation at every single point along that line. And they're also going to have a consistent contour interval, which means that they're going to change by the same number each map. If a map has a contour interval of 100, that means each contour line is going to be changing by 100. And it's going to stay that way throughout the entire map. All right, so let's take a look at gradient. So gradient is a mathematical value for how steep a slope is. So the larger the value, the steeper our slope is going to be. Now we're going to be using a formula called the gradient formula, which is located on page 1 of your reference tables. That's the front cover. And there's that formula for gradient. So our formula for gradient is going to be change in field value over our distance. So the field value is going to be whatever it is that you are measuring. In this case, it is going to be our elevation, right? So we're going to be looking at our change in elevation. The second part, distance, is going to be how far apart those two things are from each other. So if I am looking at this question that I have in front of you, it says the bottom of a hill has an elevation of 220 feet. The top of the hill has an elevation of 405 feet. The distance between these 2 points is 1.1 miles. So we're going to try and figure out what the gradient is in this problem. All right, so let's take a look at it. So according to this, we have the bottom of a hill has an elevation of 220 feet, and the top is 405 feet. So to get our change in field value, we're going to have to subtract these two numbers. So I'm going to, right over here, I'm going to write 405 minus 220 feet. Label both these. Let's see what that equals. So I'm going to get an answer of 185 feet. So I'm going to put that right here as 185. Then I need to see what my distance is. So for this example, they actually give you your distance as 1.1 miles. So 1.1 miles. And I'm going to input this into my gradient formula, which is up here. We have change in field value over distance. So I'm going to go with my change in field value, which is 185 feet. 185 feet divided by 1.1 miles. Let's see what I get for that. If I put that in my calculator, I end up with an answer that's 168.1818. We're going to round that to the nearest tenth. So I'm going to round that to 168.2. So I'm going to say that equals 168.2. And my units are feet per mile. I'm going to write that right here, 168.2 feet per mile. Now, let's say they didn't give us these numbers and we were just looking at this on a map. The closer my lines are together, the steeper my slope is going to be. The further apart they are from each other, the more gentle or less sloped my landscape is going to be. Now I quickly want to show you how to do this when we have an actual map to look at. Oops. Now I want to show you this real quick, how to do this when we have an actual map to look at, when none of the numbers have been just straight given to us. So this question, it says, what is the approximate gradient from point A to point B on this map? And we have a couple of choices there. So the first thing we need to do is we need to locate point A and point B. So point A is right here and point B is right there. So I'm going to start with my higher one, which is point B. So point B is located on this contour line right here. So it has an elevation of 300 feet. Point A is located on this contour line, so it has an elevation of 250 feet. So I'm going to start finding my change in field value. Because remember that formula, change in field value over distance. I'm going to go 300 feet minus 250. What's that going to give us? My change in field value is going to be 50 feet. Now, I need to look at what my distance is. How am I going to figure that out? Well, I'm going to use a piece of scrap paper. I'm going to take a piece of scrap paper here, and I'm going to line it up with my line, and I'm going to mark off A and B. I'm then going to move that down to my scale right here, and I'm going to line it up with the 0 and see what my total distance is. So if I look here, we got both these lining up with the 2. So my distance is going to be 2.
Cadence Camella to the counseling office. Cadence Camella to the counseling office.
So I now move 50 feet is my change in field value, divided by 2 miles if I look at my units. So 50 divided by 2 is going to be 25, and my units are going to be feet per mile. And that's it for gradient. You're going to see these questions definitely on the Regents exam, and we're going to be using that when we do our topographic map stuff. So the next video, we're going to be talking about how to make a profile and hatch your lines.